In this video, we're going to be looking at the counter pattern. The counter pattern is something we use when we want to animate any of our sprites in a consistent way. So in this scene, I have set up our wonderful ice cream cone just on a blue background. I've assigned a couple properties for it. We of course have its position where it's created. I've just kept this the middle of the scene. Its scale is currently set to 1, and its rotation is set to 0, meaning that it's pointing normally up and down. So let's say we wanted to move the ice cream cone to the right at a steady pace. The way we want to do that is using code inside of our draw loop. We want to start with a variable block, this one, the assign a variable block. We're going to drag that here. Now if we want the ice cream cone to be moving from left to right, we're going to be using the x-axis. So remember, if we show our grid, we can see we go from 0 on the left to 400 on the right. So if our cone is going to move right, we're going to be increasing our x values. We're going to go from 200 up to 300, 400, and off the screen. So inside these blocks, what we want to do is start by taking our x property. So sprite.x, I'm going to put in the first half of this assign a value to a variable block. My variable name for the sprite is ice cream. So I'll rename this ice cream. .x is going to equal. And here's where we need to take a math block. And since I know my x values will need to increase going this way, I'm going to take the plus sign, put it on this side. Now whatever block you use on the first half of this is what you're going to want to repeat right here. So I'm going to go take the same thing, the sprite.x block. I'll rename this to ice cream. And then I'm going to put a number on the other side. Usually you want to make a small number like the number 1. So what this line of code is saying is we're going to be changing our ice cream sprite's x property or x position. We're going to be changing this and setting this equal to whatever the current x position is plus 1 more. Then when we draw the sprites for that frame, it's going to move our sprite 1 pixel over. Now the next time we go through this, we're going to take its current position again, and we're going to change the current position to be plus 1 more, redraw it. Now we'd be at 202, and so on. So when we run this, you can see we steadily move over to the right. If I wanted the ice cream cone to be moving to the left, our x values would be getting smaller. So in this case, instead of using a plus 1 on our code, we would just make this the sprite.x minus 1, and then our x values will be getting smaller. We can create the same kind of motion on the y-axis by, instead of just saying our sprite.x, we change it to be our sprite.y. And again, if we're subtracting 1 from this value every frame, our sprite is going to be going up towards the top of the screen. We can also use the counter pattern to determine the speed we want our sprite to be moving. So if I change this from just being 1 to 2 that we're adding to each property, when we play it, it starts going faster. If I were to change this, let's say now to 5, now when we run this, you see it moves much faster. So you can control the speed your sprite is moving by changing what number you are adding to the value in the counter pattern. Another thing we can do is to be using the counter pattern for both the x property and the y property of the same sprite. So think about it. When we run this code, we're going to be increasing our sprite's x value and increasing our sprite's y value on the same frames. So instead of just going straight to the right or straight down, think about what would happen. So in this case, this actually makes our sprite move at a diagonal. By changing the values we have for the x pattern and the y pattern, we can actually affect what angle we're moving at. If I were to change the y to 3, this will make the sprite move down the screen faster on the y-axis. So you see it goes a little bit more straight down, but still at somewhat of an angle. The position isn't the only property of a sprite that we can change through the counter pattern. We can do the same thing with the sprite scale, for example. So in this case, every frame we're going to change the scale and set it equal to the current scale minus 0.5. So when we make a scale number smaller, this is going to make our sprite go smaller. So now you can see it very quickly shrunk, 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 and of course when our scale goes negative, it actually inverts or mirrors our sprite. So it actually looks like it gets bigger in this case. If you want to make one of your sprites be constantly rotating or spinning, you can just use the rotation property in the counter pattern. So here we're setting its rotation to be equal to its current rotation, or think of it as its current direction it's pointing, minus 2 degrees in this case, which keeps it spinning to the left constantly. And again, if we were to change this value, let's say if I change it just to 1, we spin more slowly. If I were to put this to say 20, we spin very quickly. The counter pattern isn't just something we use in Code.org's Game Lab, but this is used in many AAA popular video games and computer games you'll see. Almost all of them will move your characters based on some form of the counter pattern, changing position properties by adding or subtracting a set value to its current property. So remember, when you go to implement the counter pattern, make sure you choose the property you want to change. Set this property equal to its current property value plus or minus some small number. If you're using your blocks, don't forget on the right side of the equal sign, you'll need to add a math block. So usually either a plus or minus. There may be occasions though where you do want to use multiplication or division. You will never want to use equivalency or inequality here. You'll always use plus, minus, multiply, or divide. And again, remember to use a small number on the right side of this mathematical symbol. Hope this was helpful. Good luck on your lessons.